If you pick up a pint of all-natural vanilla ice cream at the grocery store, you might picture the flavor coming straight from a tropical orchid, but the reality is entirely different. Less than 1% of the vanilla flavor consumed globally actually comes from a vanilla bean. True vanilla comes from Vanilla planifolia, an incredibly delicate orchid. Outside of its native Mexico, the plant lacks natural pollinators, meaning it refuses to give up its seeds on its own. In 1841, an enslaved boy named Edmund Albius figured out a way around this. He developed a painstaking technique for hand-pollinating every single flower using a tiny stick. That exact method is still used today. The math behind this process is brutal. It takes about 40,000 hand-pollinated flowers to grow 500 kilograms of raw vanilla pods. Once those pods are cured, they yield just a single kilogram of pure vanillin, the exact molecule that gives vanilla its signature taste. That level of physical inefficiency means the vanilla orchid physically cannot yield enough flavor to feed the world's ice cream habits, bakeries, and fragrance houses. The industry had to look elsewhere. Relying solely on the plant causes severe problems. Harvests are unpredictable, causing massive price spikes. In places like the Sava region of Madagascar, where most of the world's natural vanilla is grown, this volatility drives poverty and creates a reliance on child labor to meet intense harvest quotas. Decades ago, the chemical industry bypassed the plant entirely. They discovered how to synthesize the exact same vanillin molecule using petrochemicals, specifically guaiacol derived from fossil fuels. This chart breaks down the global vanilla market today. Between 85 and 95% of all vanilla demand is met by this cheap petroleum-derived vanillin. The actual bean barely registers as a sliver, but consumer habits are shifting. Shoppers are actively rejecting artificial, petroleum-based additives. They want clean labels and natural ingredients in their food. This creates a trilemma for food manufacturers. The world demands natural vanilla. The plant is far too rare and ethically fraught to supply it, and the cheap synthetic alternative is no longer socially acceptable. The solution to this problem starts with a basic biochemical reality. Vanillin is just a molecule. To your taste buds, the structure is identical whether it is laboriously extracted from a rare orchid or synthesized in a factory. To legally classify a flavor as natural, regulatory bodies like the FDA and European lawmakers maintain a specific definition. The source material has to be derived from nature, like a plant or an animal. That definition creates a specific legal opening. To legally print natural vanilla flavor on a box of cookies, the vanillin molecule has to come from nature, but it absolutely does not have to come from the vanilla orchid. If you pull the molecule out of a barrel of crude oil, it is legally labeled artificial. If you synthesize the exact same molecule out of an abundant, completely different plant, it is legally labeled natural. By utilizing this regulatory definition, the biochemical industry found a way to bridge the supply gap. They started building natural vanilla out of materials that look nothing like a bean. The process is called bioconversion. Scientists take abundant, cheap natural materials like rice bran or clove oil and extract specific starting compounds, such as ferulic acid or eugenol. These compounds are then fed into microscopic factories. Scientists use engineered microbes and yeast to break down the substrates through fermentation. Because the starting material is a natural plant and the microbial fermentation is classified as soft chemistry, the output qualifies for the label. The resulting vanillin molecule legally earns the natural designation. This chart shows the trajectory of this technology. Major flavor companies are scaling bioconversion rapidly, pushing the biovanillin market toward a projected $217 million by 2035. Flavor giants are now deploying these microbial factories at industrial scale, displacing petrochemicals to meet the surging demand for clean labels. While it might seem like a semantic trick, the rise of biovanillin represents a shift toward greener chemistry. By shifting away from guaiacol, the global food, fragrance, and pharmaceutical industries can effectively decarbonize their flavor profiles. They are able to abandon fossil fuels for one of their most used ingredients. This lab-grown solution provides relief to Madagascar. Satisfying global bulk demand with fermented rice bran removes intense economic pressure from the agricultural vanilla chain. Without the need to produce thousands of tons of vanilla pods for cheap mass-market products, the natural orchid can return to a premium, artisanal status. This gives groups like the Sustainable Vanilla Initiative the ability to successfully enforce labor protections and stamp out child labor. The next time you see natural vanilla flavor on a carton, you are seeing the result of this green chemistry. By separating the molecule from the orchid, we have found a way to decouple global flavor demand from fossil fuels and the fragile fields of Madagascar.